We're going to look at the cosine rule now. The cosine rule looks like this. It's essentially derived from Pythagoras, but kind of close. A squared equals b squared plus c squared, and the bit that you need to add on is the minus 2bc cos of a. You can rewrite this a number of ways to make a, b, or c the subject. However, I like to keep it like this. So this here would find a side, because I've got a little a squared. This here would find an angle, so the cosine of a. I like to call cosine the cozy rule, because the way I can identify if I'm using cosine is if I have two sides, either side of an angle. Now, I'm going to label this diagram because I want to find x here. So instantly, I want to find the length of x, so I know I'm going to be using this top formula. So I'm going to make the subject of this triangle this a squared value. So I'm going to label this side as a, to make that angle a. And then the other two values, it doesn't particularly matter. So I'm going to make this side here b. I'm going to make this side c, which make that the big angle b. And we'll make that c. So now I have all my sides labeled. All I need to do now is substitute those values into my equation to see what I essentially get. So I have a squared, which I don't know yet. So I'm going to have a squared equals b squared, which is going to be this 6 squared, plus c squared, which will be this 10 squared, minus 2 times b, which is 6, times c, which is 10, times the cosine of a, which we already have here, which is 76. Now, I wish I could make that more simple, but that's about as simple as it's going to get, apart from squaring these out. But I usually go ahead and just put that big ugly mess into my calculator. So I end up with something that is, I'm going to say, approximately 106.969, something like that. Approximately that value. But you'll notice I still have the square root of that number here. So a is actually going to equal the square root of 106.969. So a will equal somewhere around 10.34. So that's finding the side. It's a pretty similar process when you want to find an angle. So let's draw a new little triangle here. There's my triangle. Let's say I had the sides of 4, 7, and 9. So let's say it's asked us to find angle A, and it's stipulated that this is angle A. So that would make that little side A. I'm going to call this one B, make that side B. I'm going to say that's C there, and then that means this side C. So it's asked us to find angle A. If we have a little look at our formula for finding the angle, so the cosine, again, because I've labeled this, it's pretty easy for me to start substituting values. So I can say the cosine of A, this big angle here that we're trying to find, is going to be b squared plus c squared. Now remember, this is just a rearranged version of this equation here. If you're going to rearrange that to make cos A the subject, this is what you would get. And where was I? Minus a squared. So minus our a squared, which is our 4 squared, divided by 2 times b, which will be 7, times c, which will be 9. So now if I solve this, goes down and down and down, I find the cos of A to be something around 114 on 126. And again, I have the cos of A, so to find A, I take the inverse cosine there. So I have 114 on 126 like that. And it's going to be approximately 25 degrees, something like that. So I can pretty easily find out my angle there. Now, once I have that angle and that side, I can then refer back to my sine rule and work out the values for the rest of the triangle. So cosine comes in really handy. Now remember, it's the Cosine angle. So in this instance, I was trying to find the angle, and I had two values either side for a non-right angle triangle. And that's cosine in a nutshell.